Hello friends, welcome back. In this tutorial we are going to study about page fault and page replacement. In the next tutorials we will study about page replacement algorithms. There are many page replacement algorithms. In previous tutorial we studied about paging system. So what happens in paging system? Whenever a CPU generates a logical address, that logical address is divided into two parts. One is page number and another one is page offset. So what happens for translating this logical address into physical address? This page number should be replaced by the frame number. This page number should be replaced by that frame number in which this page is stored in main memory. Right. So for that purpose, what happens? We need to look the page table. Suppose after checking the page table it is found that this page number is not in main memory. So in that case what happens? In that case page fault occurs. So when page fault occurs, the required page is to be brought in main memory from hard disk. Suppose the main memory is full. There is no available free frame in main memory. So where we will keep this newly arrived page in main memory? So for that purpose we need to make a space for that page. So for this what we do, we select a page from main memory, right? We need to select a page from main memory, right? And what we do, the selected page is transferred from main memory to hard disk. Right. So when the selected page is transferred from main memory to hard disk, the frame which was occupied by that page, now it is free. In that frame we can keep the new page which is required now. Right. So this is called page replacement. Right. So whenever the page fault occurs, right, and we need to bring a new page in main memory and main memory is full, no free frame is available, then we need to do the page replacement. So there are many page replacement algorithms, right? So what these page replacement algorithms do, actually what happens, we need to select a page from main memory to transfer it from main memory to hard disk, so that free space is available for a newly arrived page, right? So that we can have a free frame in main memory. So for that which page is to be selected and be transferred from main memory to hard disk, right? For that we are having many page replacement algorithms, right? Now what happens in this case? What is happening? Page is being transferred two times, right? One page is transferred from main memory to hard disk and another page is transferred from hard disk to main memory, right? So it is a overhead. So to overcome this overhead, what happens, one bit is kept for each page in hardware, right? And that bit is called modify bit or dirty bit. So what happens whenever there is a page in main memory and whenever some updation is made in that page, then this modify bit or dirty bit is set, right? So whenever during the page replacement, whenever we have to transfer a page from main memory to hard disk, we check that its modify bit is set or not. If its modify bit is set, it means after bringing that page from hard disk to main memory, there have been some changes in that page, so it needs to be written back in hard disk, right? So in that case that page has to be transferred to hard disk, right? But if its modify bit is not set, it means after bringing that page from hard disk to main memory, no changes have been made in it, right? So in that case what happens, during a page replacement, right, that page doesn't need to be transferred from main memory to hard disk because it is already available there in hard disk, right? We can directly bring this required page in that frame which is occupied by that page which is selected and whose modify bit is not set.